Hello, folks. Welcome to Rational Science. And I hope you're doing better than me. I hope you can hear me well. I hope you can see me well. Today's my birthday, and I'm still congested. So, not a very good birthday in that sense. 71, turned 71. This is a vision of that. Okay, here it is. 71 revolutions of the earth around the sun. That's what I've gone through. And some people are so mean that they remind me of my birthday. They call me up and they say, "Oh, it's your birthday. Happy birthday." Oh, yeah, thank you. You know, thank you. Yeah, I don't know. 71 years is a long time. Someone the other day, I told them I had arthritis, my good friend Mike, and he said, gave me all this stuff that I should do, drink this, sleep, whatever, do exercise. And I said, look, I'll do your, your recommendations if you do 71. Okay. You do 71 and I'll do whatever you, you propose. Okay. Yeah. You can't fight aging. One of the things there that I can tell you is that, you know, um, you've got life and you've got death. And people talk about the right to life, and that's not true. Life is a privilege, okay? And death is a right, okay? We all have the right to die, and you can make use of your right to die any moment you want at your leisure, okay? And if you don't do it, Mother Nature will nudge you and, lead you the way, okay? But life is a privilege, okay? So there's no right to life. Right? Just keep that in mind. And similarly, along the same lines, people say, "Oh, I have the right to vote." No, voting is not a right. Okay, voting is not a right. Voting being a right is like you asking me for an autograph is a right. For me, it's whim. If I want to, I give you my autograph. For you, it's a privilege. Right doesn't play any role either way. And so people have to define these terms and really understand them. And okay, and one fellow sent me a little note, and he said the following. He says, "Gady proven right again." What was he talking about? Well, I defined marriage way back as one bank account. That's marriage, okay? One bank account. And he found this article in the Wall Street Journal says, "Are joint bank accounts the secret to a happy marriage?" And says not only are couples who merge finances more satisfied with their relationship, they are more likely to be on the same page about money issues, according to a study. And yeah, it's what you can say is that marriage is a single bank account, and if you don't have a single bank account, well then you're not married. Let me get this out of here. You're not married. Okay, if you have two banks accounts, you have this situation when you get married or when you take your vows. Okay, this is the two bank account version. Your vow, marriage vow. Divorce do us part. You're guaranteeing that you're gonna separate from your woman or woman from a man, right? Because each one has his own thing. Everybody's ready to run. Okay, so two bank accounts is a guaranteed setup from the start for divorce or for separation or whatever. I've been married and going on 48 years. We've had a great marriage with my wife. Ups and downs. We had a lot of adventures, and I can only wish other people to have similar luck. It's not easy to carry to be married, and nobody is trained or educated to be married or to be a father, a mother, or a husband, wife, uh, even a son, if you come to think of it. Nobody's trained to do that. You kind of learn as you go along. Okay? Time goes by. And so all I can say is I wish other people the same luck I've had, as far as marriage is concerned. Okay, anyways, I'm a little congested, so I put some drops in there. So that, I don't speak like, "Oh, I have some drops, in my doze." So I can breathe a little better. But yeah, I'm not over my congestion. Came back from vacation like that. Okay, let's get started. We're going to start with extinction again. And we had this situation where sometime back, I put this little article that came out regarding, we had a little article where the some chimps, troop of chimps, maybe 100 chimps, were found to have more genetic diversity within that troop than all of the human race, than our, 7-8 billion people. And you say, how can that be? And the article was something like this. Let's see if I can get it up here. Give me a second here, see if I can get it in there. No, I don't have the article. Okay, anyways, the point here is that there was an article that said a study, right? And again, everybody's depends on whether you believe some of these studies out there, but they did a DNA analysis of a troop of chimps out there in Africa, and they found, and several people did it, separately, several groups, and they ended up convinced that this troop had more genetic diversity than all the human race. And they could not explain it. They said, with 8 billion people, you would think that, we create new genetics every day. There's mutations going on every day. And the question is why, And so one fella asked me about that, and he says the following. He says, so what is the explanation for chimps' higher diversity if they also inbreed? Because I'm saying, inbreeding reduces genetic diversity over the thousands of years, right? So for any species that's been around for quite a while, you lose genetic diversity, not gain it. And even though you accumulate mutations periodically, daily, minutely, whatever, it doesn't, for some reason, we lose it, right? And so here are my takes on that, okay? You got to look at where a species is in its history. If you grab a species, for example, if you knew that this species is going to die in the next 100,000 years, maybe they've been around for only 100,000 years, and you're looking at the midpoint. And so they haven't had time to lose their genetic diversity because they still have 100,000 more years to go for whatever reason, right? And so the question is, are we at the beginning of our species' lifespan, or are we close to the end? And you know my answer to that. We're close to the end, very close. It's how fast also a species conquer diseases. Chimps are in a given region of the planet, and they don't migrate today, and they haven't migrated. They're always there. And so they're localized. The question is whether all these chimps have had a chance to meet different kinds of diseases that would sifted out those chimps that did not have natural defenses and create, a more uniform group of chimps. And again, that's got to do also with time. Okay, so there's two things going on in there. And then again, migration. When species migrate, they encounter new obstacles, new predators or prey, new diseases, and it takes a long time to adapt to them. Okay, and so again, if the chimps were more or less always in the same region. They haven't had a chance to, be challenged from a genetic point of view. Those are my general takes on that. Here's a graph that shows this. I put that in my Neanderthal book, okay? And it's more or less like this. Mutation rate increases as the group adapts to new diseases, climates, foods, predators, etc. So you have, a group that branches off from the mother trunk and has to adapt to a certain region. It becomes isolated from the mother trunk. And throughout this initial period, they gain genetic diversity. But then over time, they lose it because despite the fact that, they have founders effects and bottlenecks, that whittles out some of the diversity from the whole population. And it's not a smooth curve as you see there. It's really ups and downs because of, these factors. Okay, and here's what it looks like for humans. This is our curve compared also with a population curve there. You can see that for most of our lifespan, we were a very small population. And, and the genetic diversity dropped gradually, okay, throughout this time. And it was only because we were primarily hunter-gatherers, we were moving around, we were encountering new diseases, new predators, we had to adapt. And these are, this takes thousands of years. When we got to agriculture, we more or less settled down, even though we were still colonizing the land, okay? And it was only in the last maybe 500 years, you could say, that we really started colonizing the planet. The Portuguese, the Spaniards, the British, they went out there and colonized certain lands that they found. And they took diseases with them as well, But the issue is that's only happened, the era of colonization was maybe 500, 600 years ago. That's when they started building the ships that could go around the world. And 300 years ago, we had the Industrial Revolution, where we went from agriculture to manufacturing, the first few countries that started that process. And that process ended in 1980, thereabouts, when a few countries started moving into the service region. They started becoming more service-oriented and less manufacturing. And today, we're all service economies on the planet. And what's become much less part of our, not only our labor, but also of our economic GDP is, we're a service economy. We're all services. And within services, I would say in the last 20 years, it's gotten even worse because we used to do manual services, like gardening and landscaping, barbering, stuff like that, or pizza delivery, kind of use your hands. It's a service where you're still active physically, right? And that's gone. Right now, the only services we're creating are internet services. And what's internet services? It's entertainment and ads. That you can summarize it with those two words. And a society cannot live on entertainment and ads. That's my take on that. Okay, too long to explain it to those who don't have the intuition to grasp that. You cannot run a world on entertainment and, ads. So, in fact, I call it non-work. And I give this scenario where you're next to God up there in the sky, right? And you're looking at the planet. And what do you see? Well, you see the things that we made, the physical things. So you see the houses, you see the cars, you see the streets, the food we grow, the cotton fields and cornfields and so on. That we can see, that you can see from up there. What you can't see are the services, the promises, the contracts, the money in the banks, especially the numbers, that we don't see. And so if you're going to judge whether a country is growing economically, You have to look at the real things and not the abstract things such as money. You know, you can create all the money you want out of the machine, or just put a number in, another zero, in the bank account. That doesn't change reality. You still haven't built a house. You still don't have a car. You still don't have a street. You don't have, the cornfields and the wheat fields. So if you're going to judge growth, real growth, it's got to be real things. And right now we're not growing nowhere on the planet, or we're growing very slowly. Growth is really being, it's at a snail's pace, right? The other thing you got to keep in mind is regarding genetic diversity is that, we don't have new species. Here's a graph that shows, that after the dinosaurs went away, the mammals diversified. Why? Because the mammals go out there and they squat a niche. Okay? They just say, oh, I'm going to eat this food. And the other guy says, I'm going to eat this animal or whatever. And so what's happening is that you have all these animals fighting for their own interests, self-interests, these species that develop, and they evolve. And it comes a time when all the niches are taken over, because immediately every animal somewhere on the planet makes use of the resources available to it. And so they evolve, some bigger than the others, some faster than the others, depending on, the conditions, climatic conditions and environmental conditions, whatever. And so once they squat these niches, each one takes whatever is useful for them, the new animals cannot arise. Or in this case, mammals, right? Same thing happened to the dinosaurs, mammal-like reptiles, and so on, synapsids. But the point here is that, once they radiate, especially at the beginning, from that, you don't have new animals. What you have is these animals just evolving into other species as they travel the planet and encounter new environments, new diseases, etc., and new animals develop. But, you don't have new animals. And here's another view of that one, of that graph that I just showed. Okay, this is a different way of seeing it here. Okay. And yeah, what happens is you have different types of animals develop, okay, on the planet. What happens? You cannot have new animals. And, the researchers who do experiments in the labs, biology and so on, they really don't take this into consideration at all. If you're going to run an experiment, you're going to try to reach some kind of decision or figure out something in the lab. And let's say you run, I don't know, fruit flies. When did the fruit fly start? When did it start its journey? Did it start 1 million years ago? 100,000 years ago? Maybe only 1,000 years ago? Does it make any difference? Well, I think it does. It'd be nice to know, when the fruit fly started its journey, okay? And, if you don't know that, if you don't have that information, you may reach the wrong conclusions in the lab because you don't have the full history of this species that you're studying. And part of that issue has to do with these mice. The same fellow asked the question here. He says, why haven't big city mice gotten extinct since Calhoun's experiments? Calhoun ran experiments with mice where he put them in a small enclosure and he allowed them to multiply. And we had 4 couples. That was the founder's effect, the starting point. And they ended up with 2,200 mice in that same enclosure. And towards the end, they became homosexual, autistic, and eventually the colony disappeared. And he did this experiment, I think, like 30 times, or at least for 30 years, since 1948 to the 1970s, I think 75. And throughout the time, he always got the same result. Okay? So he says, is it due to the migration of rural mice? And no, the issue is the city is a bigger place than Calhoun's claustrophobic enclosure. That's one issue. That's what he was testing, what the effect was on the mental condition of these animals. And the city mice, they hunt, they nest, mate, and they go around. And these animals, the ones that he had, Calhoun had, they were always in the same place in the same conditions. And there's something there that you got to keep in mind that, there's a level of, you could say, boredom. That's one issue. And the other one is that they didn't have to struggle. They don't have to do anything. The food was there. The water was there. They had enough food and drink. So they didn't have to go out and hunt, and they didn't have that incentive, you could say, that urge to go out there and do things. And so this makes you stop and think that maybe we're in the same boat, because Calhoun reached the conclusion that humans were no different than mice in that sense. And in a way, you have to agree with him. I mean, today, we all have the silver spoon, more or less. We don't have to struggle for anything. You want food, you take some, what is it called, money? You take it to the supermarket and you buy whatever you want, and someone brought it by magic. It came to the shelves, and you take it off the shelves and buy it and bring it home and eat it. And if that's not good enough for you, well, you go to McDonald's or Kentucky Fried Chicken and just, have your fill. And so the question here is, we have it so easy in that sense. We don't have to struggle. And here we are at home, maybe watching TV, playing games, whatever, doing whatever you do, entertaining yourself, because that's the world of today, a lot of entertainment. And what's the issue there? The issue is that you don't have to struggle. You're not fighting the environment, the conditions. You don't have to worry about lions attacking you, none of that. And this is more or less the situation that the mice had. So I think you got to factor that into why Calhoun's mice, eventually ended up being extinct and lost their minds. In fact, he concluded, he says, they stopped being mice. And the question is whether we stop being humans. Okay? And the other thing you got to consider is the fact that when he started his experiment also, he took mice that were in the labs. He didn't go out into the forest hunting for mice or, at the railroad tracks or whatever. He got them from someone who already had mice. Say, hey, give me 4 couples. And so we don't know what the origin of those mice were. I mean, did he do a DNA analysis, a chromosome analysis of these mice? Of course not. And so he doesn't know what his starting point is. And again, this has to do a lot with what I said a minute ago, that, you got to look at the full history of the animal that you're going to do research on. When did mice start? And the way I look at this is that, like in the case of humans, we've been around maybe, 200, 300,000 years. Big window there from 200, 300,000. What do I mean by that? I mean that if any of you today, female or male, doesn't matter, or in between, today we got to mention those as well. You go back in time, 200, 300,000 years ago, and you have sex with someone in those days, you probably would still have a viable children, something good comes out that can continue reproducing. But the farther back you go in time, beyond 300,000 years, 400, 500,000 years, well, at some point, you're going to reach a human that gave us origin, or that was in our lineage, with which you cannot have viable kids. And you can say at that point, that's a different species. The species starts at reproduction. And then that's my definition of species, reproduction. Okay? And so the question is, what is the case of the mice? When can you take one of these lab mice, take them back in time and say, this mouse can still reproduce with this other mouse over there, and beyond that, he cannot. Okay? So this is the kind of question that a lot of these researchers don't ponder or don't include in their studies. And this is something you got to think about. Okay, here we have a nice situation. We have chimps use military tactic only ever seen in humans before. And it turns out that these chimps, one troop looks at the other troop, they're enemies, they're different countries, different lands, sort of like, the United States and China, something like that. chimps from different sides of the Atlantic or Pacific, right? And it says researchers observed 2 Western chimpanzee communities in Africa take to the hills to carry out surveillance of each other, much like reconnaissance missions used by militaries. Okay, they then use the intel to decide when to enter contested territory. Okay, and so yeah, they look at each other and they say, oh, they do a little study, kind of spying on each other to see if they can have some advantage in their wars. Okay, so chimps, I guess we carry it in our bloods. We're kind of chimps, aren't we? All of us. And here we have 2 chimps. One is the U.S., the other one is the Chinese. And one of the chimps, the U.S. is quietly arming Taiwan against a Chinese invasion, but it could backfire. And it's saying the Biden administration is treading a precarious balance between not aggravating China's nationalist President Xi and providing Taiwan with the weapons it needs to potentially fend off China's vast military, analysts told Insider. And there you see the map made by the Chinese military, how they would attack Taiwan, little island there. They would attack it from the mainland, let alone, with their own airplanes and ships and whatever. And so, you could say that maybe China is getting ready for a war, which is supposed to happen maybe in 3 or 4 years or thereabouts. And they want their province back to be part of the mainland China. And I think that's one of the reasons she came to San Francisco the other day, and had to talk with Biden. I guess their main point is, we want our island back. We want you guys out of here. And part of the problem is that, you have Taiwan Semiconductor over there, which is the #1 distributor of chips, not potato chips, but integrated circuits, right, in the world. And it's not so much that that's part of it. Part of the equation is that they're the #1 distributor, but the other part is that they have a lot of technology in their fabrication areas. And imagine if that would fall into the hands of China. Suddenly they advance like 8 or 10 years in their technology because now they have it right there. It belongs to them. So they don't have to go and steal it through spies or whatever. They have it there. And so there's a double whammy there. They're a little worried about China grabbing Taiwan primarily because of that. There are other things that Taiwan has. And, the United States has reached an agreement with China. They have this one China policy. China's the communist China is the real China, and the other one's not a China. It's not part of the world. It's not a country. That's officially what's out there. But then they have this fine print where it says, hey, you can take over Taiwan, but in a peaceful manner, meaning that Taiwan has to agree. Imagine if California had to agree to be part of the Union, I don't think the United States would like it, and that's more or less the situation there. And so the question is whether there's going to be a war in 4 or 5 years, on top of the wars we already have. We have one in Ukraine, another one over there in Israel, Palestine, whatever side you take there. And it's going to be quite interesting what's going to happen in the next few years, okay? Because China is improving its military capabilities. On the one hand, it's also going out there and influencing other countries economically first, and maybe later on with military. And so, China's growing. The United States is stalling more or less. Its economy is not growing as fast as it used to. China's growing at a faster rate right now because it was so far behind. And the question is, at some point, there's going to be a rivalry there. Not to mention that we have another empire over there called the Russian Empire. You have these 3 empires that run the world. And, so the question is what's going to happen with all that. You got to stop and think. I don't think it's going to be resolved peacefully, primarily because Mother Nature she's not a peaceful woman. She wants war. She works through conflict, not through agreements. The lion doesn't reach an agreement with rivals such as the hyenas, or even with its prey. The lion knows what it's got to do. In fact, lions fight lions. There's no agreement between lions. You don't reach agreement. You fight. You have to kill, have to murder, get rid of the other side. And so think about that. There's got to be no peaceful solution when you have two empires clashing. In fact, Alexander destroyed the Persian Empire originally, and then the Roman Empire destroyed the Greeks, and so on. And it went on and on and on. It was never peaceful. Okay? So I doubt very much there's going to be peace when the interests of many people are at stake. Okay, and talking about that, here we have good old Putin, and he says that the West is increasing risk of weapons of mass destruction being used. So we have that added to all the rest. We've got these guys who are, playing around with fire, and I mean real fire, and it says that, essentially that the war in Ukraine, they're all talking about pressing the red buttons. And so the question is whether it's going to get to that point where at some point nobody cares, or someone doesn't care on one side, one of the empires doesn't care, and it says, hey, I'm just going to press the button. I'm not going to lose my job, because the other side won. Before I go, I'm going to press the red buttons. And so you got to think about that. When you're up there and, especially in the case of Putin, he's being hunted. He can't travel the world because the courts are going to get him. A guy like that, when you push him against the corner, and he's the boss of the empire, he's the emperor, right? I don't know how far you can push him. So I can't imagine how Ukraine can win the war, because when it's about to win, they're going to press the red buttons. And again, Mother Nature doesn't work through peace. She works through war. Okay? She's a nasty old witch. You can change that first letter if you want. And here you see also what's happening to the U.S. economy, why Putin is saying, the United States is in trouble. These are polls that they had out there. And they're saying, the United States is running into some kind of trouble. You have recession fears, inflation fears, and then job market booming. Well, a lot of people think that there are problems with the job market. And then also the U.S. economy leads the world. But, compared with other developed nations, the United States is not doing so great, And so at least this is the sense that people have, the people who participate in the polls. But it gives you an idea, in a way, if people are suffering, if people are feeling the impact of what's going on in the global economy. Because if everybody is, in great shape, the numbers would be in reverse. You would see more people saying, no, everything's peachy. And I don't care what's going on out there. I'm doing fine, So people would, in general, vote in favor and say, no, we're doing fine. But when people say we're not doing fine, it's because they're feeling the impact of what's happening out there, okay? And so you got to look at the polls, because it's a way of getting a feel for whether what's happening in the economy is affecting them, okay? And, the United States is now stalling a little bit. Its economy is stalling, and it's growing at a very slow rate. And here's part of the reason, okay? Here's the world population, okay? You can see how it's grown over time. I think this starts at the beginning of the Christian era. Let's see, I think so, yeah, thereabouts. Okay, so it starts at the Christian era, and you can see how we progressed over time. And what you're seeing there is not only population, which is what that graph shows, but population implies, construction. What have you constructed in throughout this time? Okay, and again, if you're out there in outer space and you look at this, you would see, and you were there also eternally for the last 2,000 years, you would see how the world expanded as far as its economics. In other words, what we constructed, real stuff, And you say, okay, we were here very little. We had these teepees and tents, and from there we built houses, and now we build these big skyscrapers. You would see, the world growing. And the question is, is there any more room for growth? There's room as far as space is concerned, how much room we have. That we have. But what we don't have is the stimulus to keep growing. The stimulus first involves more population, which is not happening worldwide. And the second one is that we should be constructing, doing more manufacturing and work that builds infrastructure. And that's not the big part of the economy anymore. Okay. What you see growing now is, again, a lot of abstraction, internet services, and you cannot have those growing and say, oh, we've created jobs. Yeah, you created jobs, but they're fake jobs. I say that services is not a job. Services means you're unemployed if you're doing services. Okay, that's the way I look at it, because you're not creating anything. And, in the end, it trickles down. It does trigger or stimulate manufacturing and agriculture, but not to the degree it used to. See, when population was growing exponentially, there was exponential growth of both agriculture, you needed more food for more people, and manufacturing. But when services overtook manufacturing, now you're creating jobs in an abstraction that is not real growth. It's fake growth. And so when they say, oh, I'm working in services, well, you're unemployed. You're a bum. Okay, one fellow says, changing the subject a little bit here, you should look into the Jews as Neanderthals theory. Actually quite convincing. Well, I did a video on Jewish Neanderthals. You can look it up. Okay. And one of the fellows who vouched for that theory was this fellow. His name is Stan Gooch, and he develops his hybrid origin theory. Cro-Magnon man evolves in northern India. Neanderthal man evolved in Europe and the Middle East. 35,000 years ago, Cro-Magnon abandons India and heads west through the Middle East into Europe, overrunning Neanderthals. By 25,000 years ago, the predominant type in Europe is Cro-Magnon. In the Middle East, a hybrid population emerges. That's, in general, his theory, a summary of his theory of this fellow. And so while they were in the Middle East, he's talking about a hybrid population emerges. Okay, well, I have a different take on this whole thing, and I did cover it in my Neanderthal video. And here it is. I think one picture is worth 1,000 words. Here it is. Neanderthal was an Arctic species. He was a hairy monkey as far as I'm concerned. Okay, he didn't look anything like us, or in other words, he was a 2-footer, okay, instead of a 4-footer. But I'm saying in general terms, I think he was quite different. You can tell the difference between a Neanderthal skeleton and a human skeleton. And I'm not an expert. All I can tell you, I look and I can see the differences, okay? And I think anyone who looks at a human skeleton and a Neanderthal skeleton can tell the difference. Now, Neanderthal grew in Europe, like this fellow says, and I have a hard time believing that he would go to sunny Israel or Iraq or Syria, right? To hunt what? To hunt camels? I mean, he was hunting mammoths and woolly rhinos and other animals that were popular in the north. I don't think the Neanderthal ever migrated beyond Europe. Okay, so the Neanderthals that they say are Jewish Neanderthals, in regions that today form part of Israel, I don't think they were Neanderthals. Okay, and you say, well, what do you know? Well, I don't know anything. Don't worry about me. I'm just saying that there's a couple papers at least that I have out there of people from Israel who studied them, studied these Neanderthal alleged quotations on that, Neanderthal bones from the caves in Israel and Iraq. And they came to the conclusion that they're not your classical Neanderthals, meaning the bones there, the skeletons, the especially the heads, don't match quite readily the Neanderthals that you find in Spain and France and Germany. They're different. They're noticeably different. They measured many aspects of their bones and so on. They say these are not Neanderthals. And so it's not me saying that. It's people out there in Israel who studied these bones. All I can say is look up papers that talk about the so-called Jewish Neanderthals, in other words, so-called Neanderthals that were found in caves in Israel and Iraq primarily, and you'll find that they haven't reached an agreement. But I think all of them agree that there are differences. The experts who look at these bones, they see differences between the bones in Europe and in Israel, right? Now, are they a different species? Well, that's for you to reach your own conclusion. I say they're not. Okay, so no, there was no inbreeding or interbreeding between Neanderthals and humans. As far as I'm concerned, they were two different species. If a Neanderthal found a human, he would have killed him and eaten him, and vice versa. Okay, I don't think they would have shook hands and drank beer together and swapped wives. I don't think that happened. Okay, and here's something to top that one on. It's a new theory how Neanderthals DNA spread in Asia. And researchers have discovered that Neanderthal interbred with the ancestors of Asians at 2 points in history, giving this population an extra infusion of Neanderthal DNA, European DNA. What's the issue here? The issue is that we had this fellow, his name is Svante Pääbo, and he's part of the Max Planck Institute. He did a study from, I think, 2007 to 2010, where he issued his report together with his group. And they came to the conclusion that Neanderthals, that we have Neanderthal DNA, but it's not as clear cut as you would think. The way they presented their report is that you have non-Africans have more Neanderthal DNA than Africans. That's the way they presented their report. They lied. They lied because they omitted a very important point, or they put it really in a very fine print, which was never dealt with ever again, and that is that American Indians and Papua New Guineans have more Neanderthal DNA than Europeans. And you would say, well, how is that possible? I mean, if Neanderthals were in Europe and they mated with humans in Europe, with the Cro-Magnons, right? Why is it that these faraway places, American Indians, Papua New Guineans, have more Neanderthal DNA than Europeans? But they don't put it that way. The way they presented, or what they emphasize, is that non-Africans have more than Africans. So they lied by doing that, and they never dealt with that subject ever again. Okay, one fellow says, does money exist? You said that when money is no more, humans will become extinct. So you also say that existence equals location plus shape. Not true. What I say is something a little different, okay? And here it is. Say exists is object plus location, not location plus shape. Shape is an adjective, okay? And we're saying that it's got to be the word object. You can't change the words on that definition. That's the first thing I need to point out. And so does money and or trade exist? It was an invention of civilization. If money had a standard and was backed by gold and silver, then it would exist. What's your take on this? And here's the take on this, okay? Shape is an adjective, okay? And it is irrational to say that a concept exists, okay? So what we have is money is a static concept, okay? And you give value to this thing we call money, and it's in your mind. It's not out there. It's in your head, right? And trade is a dynamic concept. Trade means you're going to exchange something, okay? And so gold, the rock, that's an object. That's a thing, okay? Let me put this over here. That's a thing, okay? And give me a second here. And paper money is also a thing. So you can say that gold, the rock, right, the metal, right, that exists. But you can't say money exists because money is a concept that you have in your brain. Okay, so you can't say that money exists. So you have to be careful to distinguish the object from the concept. Gold exists, the paper money, that exists. The paper exists with the ink on it, right? That you can say exists, but you can't say money exists or trade exists because those are concepts. One is a static concept, the other one a dynamic concept. Okay, we had a visit from the aliens, and here they are, 2 aliens they found in Peru. They say that they only have 3 fingers, and et cetera, et cetera, et cetera. Okay, I don't know what these 2 mummies are, okay, but I can tell you one thing for sure, 100% sure. They don't come from another planet, okay? It's impossible for life to travel interstellarly. I'm on record with that, okay? You can look up the Pioneer Anomaly video that I made and get acquainted with the theory, but it's impossible to travel interstellarly. We have no chance of ever going to the nearest star. We can only look at it from, the telescope from afar. But we cannot travel interstellarly, and so no life, no living entity can travel interstellarly. That's the position we take here. There's a theory behind that. I'm not going to go over that right now. You can ask the question someday, okay? So all I'm saying is you can't travel interstellarly. Whatever those 2 mummies are, they don't come from outside the Earth. Whatever it is, it came from within the Earth. It could be a hoax. It could be for real. Who knows? Maybe they chopped 2 fingers off for all I know. I mean, I don't know. But they don't come from abroad, meaning, from another planet, from the land of the Klingons. And the final issue here is autism, okay? And again, this has to do a little bit with the Calhoun experiment, okay? Fellow says, diet is more powerful than most people think. And so the fellow goes out there saying, that autism might be caused by some environmental or dietary those would be the causes. Okay, that's the source. And I think it's the same fellow. He continues. He says, maybe it's not, but I don't know. I don't remember now. Autism, I think it's a combination of dysgenics and vestigiality. And he goes on defining both of those. So if you turn off certain genes in a chicken embryo, you can get them to grow dinosaur-like faces. Why does he say that? Well, he says that because the theory right now is that dinosaurs, or that came from some kind of feathered animal in the past. They found one here in Germany, which I went to see, by the way, and that's that dinosaurs were more like chickens. And I have no problem with that, except that, we have to be careful with extrapolating, saying, oh, the dinosaurs are still alive because all these birds, they're dinosaurs. That's a long stretch. Okay, so the fact that dinosaurs could have had feathers does not mean that chickens are dinosaurs, okay, which is more or less what these people conclude. And they just state that like if it was a fact, instead of, pulling back and being a little bit skeptical about that theory, okay? Anyways, we define autism, and here we have it. Autism, the psychology of hunter-gatherers. This fellow defines it as such. And he continues saying that, this is a vestige from the old days, that we've got some of these genes inside of us, and they pop up in this day and age. Okay, so that the reason we have autism today is that it's just in our genes, and they just popped up again, okay, after many generations. And, he says the reason we know that the autism is vestigial is because the brains of allistic people are smaller and have fewer nerve connections, just like all domesticated animals. And it is the reason why the average person comes across as thoughtless livestock. Why does he say that? Because he says that he's autistic, but he's very intelligent. He's saying that he's intelligent. Okay? So he's trying to justify why he's an autist and so intelligent. And he says, because the average person is not. To some degree, I would agree with him saying that, the average person is not very intelligent, or maybe they don't investigate things, which is maybe not different, a little different than saying intelligent, but no, I'm saying that I don't think it has anything to do with vestigial anything. It's not autism. That it has very little to do with what happened in the past. I'm saying that we are becoming more autistic because of what Calhoun showed in the lab. In other words, that if you have inbreeding several generations, at some point you're going to have problems, mental problems, especially in a crowded environment. And that's what we have today. We have humans living in cities, which are very crowded, right? We have these enormous ant holes. We're not creating new cities. There's ample room. I mean, all of Russia, biggest country in the world, 1/8 of the surface of the earth, completely empty. And the Russians are now in population decline, especially after the war with Ukraine. And why is that? Well, because, people live in cities, and in cities you don't have kids. And nobody's moving out of the city to create new cities in the middle of nowhere. Why? Because, everybody does exactly the opposite. They go from the villages to the big cities to get jobs, primarily in the service industry. And so all this land is just going to, when we all die, when humans disappear from the face of the earth, we're going to find, if the Martians came here a million years later, they would find that all this land was not occupied. They had all this land, nobody lived in it, and all the people were crowded in these cities. Why? Why didn't they go out there and populate, all this vast land that was empty out there? Well, because the era of colonization is over. Okay, we don't colonize anymore. We don't spread out and colonize the land anymore. We're not going to be founding new cities. And so, this is how humans are going to end. And just as icing on the cake, I just want to clarify that autism, there's short-range over-connectivity and long-range under-connectivity. In other words, different sides of the brains are not connected in an autistic person. So it's not that they have more connections or fewer connections, it's that they have the wrong, quotations on that, connections. Parts of the brains are not connected as well as in a normal human being. So if you're autistic, it's not because you're so intelligent, it's because you don't have your brain connected. And so for tasks that require us to combine or assimilate information in different parts of the brain, like social function and complex motor tasks, individuals with autism have more trouble. Okay, that's more or less the conclusion of the doctors, of the researchers. You can take it, with a grain of salt if you want. And then just in case, here's the case for Down syndrome. Individuals with Down syndrome suffer from developmental delay, intellectual disability, and an early onset of neurodegeneration, Alzheimer's-like disease, or precocious dementia due to what? An extra chromosome 21. What does this mean? It means that, when you say, this person suffers from Down syndrome, people say, well, yeah, he was born that way. Well, when you say this person is autistic, a lot of people say, well, it's what he ate. It's the environment. It's all this poison that all the companies are putting in our foods and who knows what. It's the air we breathe, the pollution. So you don't say that for a Down syndrome because that's so self-evident. And the only thing there a person might say, who believes that it's all environmental and food, they would say, well, it's their parents who ate the wrong stuff, and that's why the kid came out like that. Well, I'm not sure if eating, is going to change your chromosomes, even for your children. I think something else is going on, and again, I stick by my words that this has to do with inbreeding after thousands of years, and now we're suffering the consequences of that. On the one hand, it was good because, our forefathers, our great-grandfathers especially, they went through this sifting process where they encountered diseases. Diseases killed those that had no natural defenses, And those who went ahead, they had children, and those are our forefathers. And that's why, if you look at today, a Japanese, a Russian, someone from Africa or South America or Europe, we're all clones of each other. And you say, well, why is that? Well, it's because our forefathers, whether in Japan, in Africa, in Europe, in South America, they went through the same sifting process. Those who made it across, they all had similar DNA, chromosomes, and so on. And those who died did not have the natural defenses to overcome some of these diseases. That's why we're all the same today. And it doesn't matter if you're Japanese or Indian or whatever, we're all clones because we went through the same sifting process thanks to our forefathers. And that's good as far as, your health, the fact that we don't die of diseases these days in this day and age, especially childhood diseases, the whooping cough and so on. We don't die of those things anymore. We die of old age today. But at the same time, we are all clones of each other, and now we're having genetic diseases or ailments or problems, right? Disorders. Why? Because we've been inbreeding for so long that now we don't have to worry about contagious diseases. We have to worry about genetic diseases. That's my take on that. Okay, let's move on to the subject matter of today. I'm going to start with some questions and comments that people made because it leads us into the subject matter, which is Mr. Feynman, Dr. Richard Feynman, Dickie Feynman, okay? And so let's start with this. Paul says, physical, he says, relating to the body. Where did he get it from? He got it from, he just copied and pasted from the Oxford Dictionary. It says relating to the body as opposed to the mind. And it also says relating to things perceived through the senses as opposed to the mind. Talking about touch and see and touch. Famous see touch. They say mathematicians think that anything that you can see or touch is what an object is, what physical means. And that's not true. Okay, that's an irrational definition, because if you can't see or touch it, is it physical? For example, the table the Klingon has on the other side of the universe, which you cannot see or touch, is that physical? You say, well, he can see and touch it, or I can see and touch it if I travel over there. Well, that's not fair, because you're saying that until you run the experiment of seeing and touching, it's not physical. So you're going to wait for an experiment. Until then, a table is not physical. See the problem? Okay, so, but here's this fellow's contradiction. He says, physical presences are forms, okay? An object is a form which has physical presence. And then he tops it off and says, there are physical presences other than objects. See, we went all around in circles, okay? Yeah, I'd like for you to mention which physical presence which is not an object. Okay, we'd like to know. Okay, the fellow just states that he's saying, an object is that which has form, which has physical presence, but there are physical presences which do not include objects. I don't know. He's talking about ghosts or spirits. I have no idea. Which again, if it's physical, and you're talking about see touch, right? Because that's what it is. Well, I don't know. He's got to explain that. Okay, another fellow questions the ropes, especially in regards to gravity. And he says, I don't know if your hypothesis asserts objects closer to each other have more connecting ropes. Okay, if so, what mechanism adds or removes connective ropes? And the mechanism is known as distance. And I don't mean the distance of mathematics, which is distance traveled. I'm talking about separation, qualitative separation. The closer two objects are to each other, since every atom from one object is connected to every atom of the other object through these ropes, the closer they get together, the ropes fan out. So you're not creating new ropes. You're not saying, oh, more ropes entered from, outer space or whatever. No, what you're saying is the objects are already connected. And as they get closer to each other, you can see what's happening there. The ropes fan out. And it's that gradual fanning out, which is the acceleration of gravity. The closer they are, the more the rows fan out, the faster you go because of more and more rows fan out. That's the mechanism we propose for gravity. That is the acceleration of gravity, or the mechanism of the acceleration of gravity. Here's the single thread, okay? See if I can get it here. No, I don't have it. Okay, anyways, we have a single thread. Let me put this other one here. See if this one is okay. I didn't check these out. No, I don't have either one. But anyways, what I wanted to say is that you have the single thread. That's our hypothesis. That's our assumption, that there's a single thread throughout the universe. This thread weaves every atom and every rope that connects any two atoms. So there's only a single thread. If we would take every atom and disassemble it, and disassemble every rope, we would end up with a single thread in the entire universe, a single closed loop thread. Okay, and this single closed loop thread, you know, when you weave it, you weave the atoms and the ropes that interconnect them. And so there are no more ropes that come out of nowhere and, you know, come in between two objects. That's not the theory. The theory is that as two objects approach each other, the atoms that are connected by these ropes, the number of ropes that connect these two objects is a fixed amount, because it's from one atom to another. And we're talking about hydrogen atoms. And we don't care if it's uranium, 92 protons and electrons, right? 92 hydrogen atoms, and 205 or 208 neutrons, okay? We're talking about, you know, them coming together, and the ropes fan out. So we're not creating new ropes. Okay, I just want to clarify that for those of you who are not familiar with the theory. Okay, and here we have another fellow. He says, how do we tell the difference between the blue stuff and the black stuff if it is both invisible and intangible? And this fellow proposed that the thread, you know, the rope model, that's an ether. And I'm saying, no, it's not an ether, because ether is a bunch of particles. And so I said, you know, I put the challenge out there for anyone who can come up and tell me what the ether looks like. And he said, well, your ropes are an ether. I said, oh, is that true? And he drew it, and this is what he illustrated. And the problem here is that we have three things. We have the black stuff, we have the round white stuff there, the supposedly the atoms, I guess, and we have the blue connections, which apparently are the ropes, okay? And so he said, how do we tell the difference between any of these if we can't see them? And the issue is, it's not a question of seeing. The first thing we do in science is what they do in the mafia. We wipe out the witness. We kill the observer. There are no observers in science, in rational science. Observers exist only in mathematical physics, in the religion of mathematical physics. And so we have no observers. Here you have to tell the crowd what you mean by ether. And the guy says, phantom thread, ether. I don't know which one of those is the ether. Is it the white stuff, the black stuff, or the blue stuff? And he said, well, I can't see them. Well, you have to make them visible. In fact, you did make them visible. And so you have to tell me which of those three things is the ether. Right now, you can't say all three of them are the ether, okay? Because ether can only be one object if you're going to treat it as an object. If you're going to say that the thread is an object, okay? And, you know, when I show the thread, I show a single closed loop thread. And in fact, this is what it looks like. Here it is. That's what I'm saying. It's a single object. Now, this object, you know, as it twines around, turns into ropes and into atoms, okay? But here, this fellow is showing something different. In fact, he shows that the blue stuff is separate, something different than the white stuff, because the blue stuff is all connected together, but it doesn't blend, like in my hypothesis, it doesn't blend with the white stuff. Otherwise, he would have painted him white. And if we paint the black stuff white as well, then we have nothing. So the ball is still in his court. He's got to tell us what he means by ether. Okay? And if it's an object, we don't want you to define it. We want you to point to it and name it, illustrate it anywhere on the internet. Okay, here we have another fellow says, this theory is the best description of gravity yet with numerous evidence across all fields. Evidence. You should be less skeptical about it, even though this thought experiment might seem counterintuitive. Okay, also give Brian Greene, or Brain Green, I guess, a chance to explain the troubles of the Newtonian alternative. What is this fellow talking about? Well, he's talking about good old Brain Green, okay, Green Brain. And he just pointed out to this, one episode of The Elegant Universe, which was, I guess, the biggest show that Brian Greene made, or at least one of them. And in there, he says, string theory says that we may be living in a universe where reality meets science fiction. Oh, my God. That's a bad way to start a scientific theory, right, or explanation. Says a universe of 11 dimensions. 11 dimensions. I mean, I don't know how much beer this guy drank, but you can see him drinking there, right? With parallel universes right next door. Okay, and so they have all these parallel universes. You can see all the magic stuff he put out there. He's saying this is physics or science or whatever. String theory is surprisingly simple. Okay, it says that everything in the universe, from the tiniest particle to the most distant star, is made from one kind of ingredient, unimaginably small vibrating strands of what? Energy. Vibrating strands of energy, which he calls strings. Okay, well, what can I say? There's no such thing as energy if we knew what it was, and we're going to be discussing that with good old Dick Feynman today. But question is, this guy's talking about many dimensions. He's saying that it's very simple to understand. Is it? And he shows us magic tricks, unexplained magic tricks. He just says, we don't know the cause, we don't know the theory, we don't know the explanations, physical interpretations, we don't know the mechanisms, but it is so. Okay, so no, not much to learn from good old Brian Greene. Another fellow, more or less the same thing, he points to Dr. K. He says, here's Professor Alex Kantarovich, okay, I'll call him Dr. K, who goes against definitions themselves in maths. I thought it might interest you for one of your various points, okay? And this is what good old Dr. K has to say. He says it on the Veracitum program or series of Derek Miller. And they're referring to Euclid's definition of geometric figures, point, line, and plane. And good old Alex K., this professor, he says, don't give me a definition that's going to have an infinite recursion. Okay, so he doesn't want you saying, defining and then saying, and this definition of this word is this, and then goes and tries to define every word of that definition as well. So he doesn't want an infinite recursion. And Veracitum asks, are the definitions a bad idea? And so what does K say? He says, you shouldn't have definitions. You should have undefined terms. Now, this is a professor, okay, who's saying this. So he says, you got to have undefined terms. In fact, to this day, point, line, and plane, they remain as undefined terms, and these point, line, plane, they remain undefined. They have no way of defining them, admittedly, okay? So all these people who teach geometry say these are undefined terms. He says, I'm not going to tell you what a point is. I'm not going to tell you what a line is. I'm not going to tell you what a plane is. All I'm going to tell you is what the postulates are that they're assumed to satisfy. It's the relationships between the objects that's important, not the definitions of the objects themselves. Well, poor old Dr. K did not realize that, you don't define objects, okay? You point to them. And so you define concepts. And point, line, and plane, what are they? They're called what? Geometric figures, right? So if it's a geometric figures, you're not going to define it. You're going to point to it. And there, just so I educate Dr. K or Professor K there, not to compete with Kevorkian, who was Dr. Death, right? Also Dr. K. But Professor K should learn that, there you have the pictures. You have a point, you have a line, and a plane. What is a point? Well, you can see objectively what's coming out of the screen into your eyes. Now, maybe you're blind. Maybe you shot up today and you can't see very well or think very well. But I'm telling you, what's coming out of the screen is objective for everybody on planet Earth. Okay? Whatever you interpret is a subjective. But what's coming out of the screen is for the word point is a 2D dot. That's what's coming out of the screen. What's coming out of the screen for line is a 2D elongated rectangle. And what's coming out of the screen for the word plane is a 2D square. Okay? So they're all 2D. They're all two-dimensional, these objects. In fact, there's no object that is neither 2D or 3D. All objects are 2D or 3D. There's no object that is 1D or 0D or 4D and above. Okay? And so why do they say that the point is 0D? Why do they say that a line is 1D? Well, because they're referring to location and itinerary respectively. Okay? So they say, well, location. Well, why did you put a dot? Why are you pictorially representing the word location with a dot and calling the whole shebang a point? Why are you representing an itinerary with a line, and it could be a dotted line because that's the way they usually put it, because each dot is a location, right? Meaning they're talking about an itinerary, and they're saying that's 1D. Well, an itinerary is not any D at all. And a location is not any D at all either. They're not 0D and 1D. An itinerary has nothing to do with dimensions because it's not a physical object. So you either talk about the figure, the geometric figure, or you're going to be talking about, concepts, dynamic concept like itinerary, or static concept like location. Okay, and here, just to rub it in a little bit, is this what we're going to do here? We're going to represent love with a heart. Is a heart 0D, zero-dimensional? We're going to represent intelligence with a brain. Is a brain one-dimensional? Are we going to say that grace is represented by God, a three-dimensional being? Is that what we represent concepts with, pictorially represent them with? So again, you cannot represent concepts with objects. That's okay if you want to do a little poetry, little art, no problem. But don't bring it into science. Don't bring it into physics and tell me that a heart represents love or that a point represents location. Okay? And this is where the problem is. That's why they say we can't define it. Of course you can't define it because you're confusing concepts with objects. You're trying to represent a concept such as location with a dot, and you're calling the whole thing a point and think you can get away with that. Not in physics. Point is 2D or 3D. You can have a ball represented, no problem. But you cannot say that that represents location. Location has no pictorial representation. Okay, and the final issue here, a little article that came out, I thought I'd rub it in there. It says, see the first astounding images from the Euclid Dark Matter Telescope. Dark Matter Telescope? What the hell is that? I thought dark matter was invisible and intangible, and these people have a telescope? The Euclid telescope to what? To see dark matter, I guess. That's what telescopes are used for. And yeah, the issue here is that these people don't look at dark matter. They're looking at the same thing for which they don't need to see any more than what we see out there with a common eye, and that's you see the visible stuff. So with a telescope, okay, so you can see farther out in space, meaning you can see maybe the galaxies and even some of the stars of the galaxies. You can see the visible stuff. You're never going to see dark matter because by definition, dark matter is invisible, intangible, right? Also. And so, you need no telescope for that. What you need is to make a proposal, what you think dark matter is, and make it visible to the eyes, just make a hypothesis, an assumption, supposition, and say, look, this is what I think dark matter is. And you can represent it with particles as they do, no problem. But then you have particles. And you don't need a telescope for that. You just need to make an assumption of what you think dark matter is. Okay? And so you can say, oh, dark matter is a bunch of particles, and they weigh a lot, and they're small, and whatever. You can describe that. And then once you do that, you got to explain how those particles create the effects, such as the galaxy rotation problem, which is means that they're sprinkled on the outside of a galaxy only, preferentially, for some reason. I don't know why. You got to tell me. And they're sprinkled outside the galaxy, and just encapsulates the galaxy. Because otherwise, you cannot explain, or mathematicians cannot explain, why the stars on the outside travel faster than those on the inside, or at the same speed or faster. Pluto doesn't travel faster than Mercury around the sun. It's the other way around. And in the case of stars, it is that Pluto would be traveling faster than Mercury around the sun. And you say, well, how can that be? Well, we can explain it. We put more mass, more matter outside of Pluto, and that would explain why Pluto can go faster than Mercury. Okay? And so they say that's what's happening to a galaxy. So they sprinkle this stuff in there, and they say there's all this matter which we cannot see, and which is translucent, transparent, invisible, whatever, because you can see the stars in the background right through this dark matter thingy. And so even if you put dots in there and say, okay, here we have all this matter, and it weighs a lot, no problem. But then the question is, how with that do you produce, the galaxy rotation problem, meaning that stars on the outside travel faster than those on the inside? You still have to answer that question, the mechanism. And even particles you cannot explain. Because in order to explain it, you would have to show how this particle is in physical contact with a star. Connection, physical connection of some kind. The ropes. Yeah, no, there is no such thing as dark matter, because you don't need dark matter to explain the galaxy rotation problem. This is very simple. And the first thing you got to explain, why don't the stars on the outside, right, especially those on the outside, but all of them for that matter, especially those on the outside, when the galaxy rotates, why don't they go flying out, out of the galaxy? That's all you got to explain. And the only way you can explain it, the only way you can rationally explain it, is if that star somehow is connected to the center of the galaxy, meaning to all other stars in the galaxy. Only then you can explain why the whole thing rotates like a single platform. You're on the carousel, on a merry-go-round, and the whole thing travels at the same speed, same time. The horsey on the inside and the buggy on the outside, they travel at the same rate because the whole platform is turning at the same time. Why? Because they're all connected. They're all on the same platform. And that's the case with galaxy. It rotates, the ones on the outside almost practically at the same speed as those on the inside, or faster, meaning they travel at the same rate around. Why? Because they're all connected. Then you can explain it. But if they're not connected, the first thing you got to explain is, why doesn't this star just go flying out of the galaxy? And it's very simple. So connection explains it all. And to top it off, the same publication, right, says dark matter may have come from a second, darker Big Bang. These people are so clueless. They don't know what to invent anymore. They have to invent a second Big Bang and to try to cover all the holes in their theories. So, you wonder about these mathematicians. It's like they have nothing else to do than come up with all this nonsense to try to cover the holes in their theory. So they create dark matter, dark energy, Big Bang one, but black holes and wormholes and so on. They have to create all these non-entities, all these spirits. In fact, spirits are probably easier to imagine than concepts such as, dark matter and dark energy. To cover their holes. That's the only reason these things were ever created. And the problem here, this is what should shock you, is that You have all these mathematicians on planet Earth, almost in every university's research center, professionals, etc., and they're studying what? Black holes and dark matter and dark energy. That's where your funds are going. Directly or indirectly, that's where your funds are going. Into the study of inexistent stuff. They're studying souls and spirits and conscience, souls going to heaven, that kind of stuff. It's even worse because, again, they're only dealing with abstract concept, mathematical concepts. And so think about that next time you pay your taxes. Coming up. Okay, so how does this lead to Mr. Feynman? Well, because he was a supporter of all this stuff. And Richard Feynman, he was a very popular teacher. Okay, very popular teacher because he was charismatic. He told jokes and so on. And here you have just an image, so that you can see why he was kind of popular with the students. He would tell jokes and talk in a friendly and also in a straightforward manner about stuff. And people like that because they say, I can finally understand this teacher instead of some of these other professors or instructors who went off into math and stuff like that. This fellow just tells it straight out like the way it is. Okay, that's why he became so popular. Okay. And good old Dick here, he won a Nobel Prize. Okay, here he is. He won a third of a Nobel Prize, right, for developing quantum electrodynamics, otherwise known as QED. What was his contribution? Well, primarily this space-time diagram. Okay, he says you got two electrons, and they send one of these virtual photons, virtual quantum, whatever, and they interact, and that pushes the two electrons away. Okay, and so this is it. This is primarily what he contributed. He got a Nobel for this, 1/3 of a Nobel. Okay, they gave him a third of a coin. Okay, fine. So this is his contribution. So how much did he know about QED? I mean, this was his down his aisle. This is what he worked on. This is what he studied. This is what he contributed to quantum mechanics, science, if you can call it science, physics. And he says, well, you understand what I'm going to tell you. You think I'm going to explain it to you so you can understand it. No, you're not going to be able to understand it. You see, my physics students don't understand it either. That is because I don't understand it. Nobody does. While I am describing to you how nature works, you want to understand why nature works that way. In other words, he had no physical interpretation, which is what physics is all about, which is what, we wanted to always know or understand, right? But you see, nobody understands that. I can't explain why nature behaves in this peculiar way. The theory of quantum electrodynamics describes, not explains, but describes nature as observed from the point of view of common sense, meaning he cannot explain it mechanistically. Why? Because he's talking about particles. That's why. You cannot explain with particles, discrete particles, how the universe works. And it agrees fully with experiment, which we don't care anything about. So I hope you can accept nature as she is, absurd. No, we cannot. We can accept that you're ignorant. That would have gone a long ways to helping people understand that the mathematicians don't know squat. That would have been great if he would have said, look, we're all so ignorant. He said it in softer terms, but I would be a little more adamant, because today people say, oh, we know it all. And you say, what do you know? Can you explain gravity? Oh, you're talking about a physical interpretation? That's philosophy. And they brush it aside. And they say, let me tell you about my equations. The problem with equations, that's a description, as good old Dickie just said. Okay? But the problem is that, that's not science. That's like saying you measured a table and you measured it to be 1 meter, and the other guy comes over and says, no, I've got a better measurement. I got 1 meter and 1 micrometer, so I'm a little more accurate than you. Okay, so you measure a table. Is that science? Yeah, measurement and followed by an equation? Or is it explaining something like gravity? Why, a famous trick here, why the pencil falls downwards, not to the ceiling. That's what you got to explain. And the only way to explain that is by making visible the invisible. You have to show me what is in contact with a pencil. And if you say, well, nothing. Why? Nothing, because, I can't see anything above or below, so there's nothing there. Well, because you're talking about seeing and touching. And that's not what a thing is. A thing is that which has shape. So you got to draw the shape that you think is connecting the pencil, or coming in contact with a pencil, because, maybe something's pushing from above, something's pulling from below, whichever, I don't care. But you got to show me what's in contact with a pencil, and for that you have to make the invisible stuff, the mediators, visible so that I can understand your mechanism. That's what it's all about. And they've never done that because they say, oh, an object's that which I can see and touch, and I can't see and touch anything there above or below, so there's nothing there. But if you say that there's nothing there, if you're talking about action at a distance, you're talking about black magic, you're talking about witchcraft. That's the problem. Okay? That means you're going to invoke black magic and say it's done by magic. Mother Nature works by magic, and that's why these people like Richard Feynman concluded that QED, or quantum in general, cannot be explained. Nobody understands it. And just in case, let's make sure that that's the case. He said quantum mechanics is the description of the behavior of matter and light in all its details, and in particular of the happenings on an atomic scale. Things on a very small scale behave like nothing that you have any direct experience about. They do not behave like waves. They do not behave like particles. They do not behave like clouds or billiard balls or weights or on springs or like anything that you have ever seen. We choose, and then he talks about, why they concluded with this. He talks about the slit experiment. He says we choose to examine a phenomenon which is impossible, absolutely impossible to explain in any classical way, and which has in it the heart of quantum mechanics. In reality, it contains the only mystery. We cannot make the mystery go away by explaining how it works. We will just tell you how it works. In other words, he's going to describe, right? One might still like to ask, how does it work? What is the machinery behind the law? No one has found any machinery behind the law. No one can explain any more than we have just explained. No one will give you any deeper representation of the situation. We have no ideas about a more basic mechanism from which these results can be deduced. And the whole problem is really comes down to the fact that, like he said, light cannot be a particle and light cannot be a wave. It's neither. And they insist on doing it with particles and with waves when he's telling you it ain't one or the other. So we got a contradiction. Instead of going to the basement, dark basement, and thinking hard and proposing assumptions, brainstorming assumptions, the guy says it just ain't particles and it ain't waves. Okay, so what is it? It says nothing like you ever imagined. Well, have they tried this? A rope. This you can imagine. In fact, I'm showing it to you right now. And a rope is neither a wave nor a particle. And now we have a different proposal here, a different universe, right? Okay, so he continues saying, the quantum mechanic behavior of things is quite strange. Yeah, because they're trying to do it with particles, in fact, which are not particles anyways, because the so-called particles of quantum mechanics are really numbers. They're concepts, and they're trying to move concepts. So when they tell you that they have a particle accelerator at CERN or at SLAC or Fermilab or whatever, they're not talking about particles. What they're accelerating is numbers. What they're doing is they're saying something accelerated, and we're going to call it a particle, and we're going to represent it with a number because we're interested in determining what the energy was and what the mass is, what the charge is. They're going to go into numbers and units. They're not going to be talking about a ball. Okay, and that's important that you know or that you understand that. Nobody has an everyday experience to lean on to get a rough, intuitive idea of what will happen. We could either describe what can happen in a rather rough physical way, meaning they can't describe it at all, right? Telling you more or less what happens without giving you the precise laws, meaning they cannot tell you anything about what's in that invisible world, laws of everything. Or we could, on the other hand, give the precise laws in their abstract form. But then, because of the abstractions, you wouldn't know what they were all about physically. Yeah, that's the point. They're not doing physics. That's the problem with these people. They're not doing physics. Quantum mechanics is not physics. It's just a bunch of abstractions, mathematical abstractions. That's all it is. The latter method is unsatisfactory because it is completely abstract. Yeah, tell me about it. And the first way leaves an uncomfortable feeling because because one doesn't know exactly what is true and what is false. Yeah, in science, we don't care what is true or false. We care about explanations, mechanisms, okay? We are not sure how to overcome this difficulty, okay? And then what is his conclusion? Okay, here, let me remove this. He says the following. He says, I think I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. They've given up on that. Okay? In other words, nobody does physical interpretations. And the worst part is that they dismiss that as philosophy. They say, we do equations. But then it's my $1,000,000 question. If they just do equations, if it's not part of their job description to give you a physical interpretation, if they don't do philosophy of physics, philosophy of science, whatever they want to call it, if they dismiss that as philosophy, if it's not part of their job description, why did they even attempt to give you a physical interpretation? Why didn't they just stay with math and say, this is what we do. We do equations and math and describe. No problem. I have no problem with that. It's when they cross the line into physics and they say, oh, let me tell you how the universe works. Okay, how does it work? Well, you have all these particles and they do all this magic. But you cannot explain it. Yeah, but that's philosophy anyways. We do math. We got a contradiction. Because if you don't do physical interpretations, don't do them. Don't do them. Don't jump the fence and try to do physics when you're not doing physics. When you can't do physics because in the end, you say, well, it's philosophy anyways. That's not part of our job description. That's where the problem is. These people are telling you they know how the universe works through their math, right? Because otherwise their math would be completely irrelevant if they cannot tell you how the universe works, how gravity works, how light does its magic. They cannot explain that in a rational manner. Then their equations are worthless. That's why they try to give you a physical interpretation. When you call their bluff, they jump back the fence and say, well, we don't do that. That's on the other side of the fence anyways. That's philosophy. That's the problem. That's where the contradiction is. Okay, so what does he have to say about light? Okay, here it is. Neither the wave viewpoint nor the particle viewpoint is correct. Aha. We would always like to present things accurately or at least precisely enough that they will not have to be changed. But when we try to talk about the wave picture or the particle picture, both will change. Therefore, what we learn will not be accurate. We will deal with some half-intuitive arguments. In other words, he has no intuition, meaning he has no proposal for what light is, because that's where you got to start. Okay, here we say, here it is. That's what light is. Light is torsion along a physical entity, not a concept, not a mathematical abstraction. It's a physical object that, binds any two atoms. My fists here serve as atoms, hydrogen atoms. Okay, and what light is, a torsion. Now we have a torsion. Now we can explain why light is so fast, because a torsion wave is faster than any transverse or longitudinal wave, okay, or any kind of wave for that matter. You have one-dimensional, two-dimensional waves. This is a 3D wave, Okay, so it's a torsion, and it's the fastest thing you can imagine. Nothing is faster than a torsion wave out there. Okay, torsion is fast because the object is already connected at two ends to the two atoms. So nothing has to travel. All you do is torque, and the signal is what is detected by the other atom. It's a thump that it receives. Okay? And that's why light is so fast. Now we can explain the speed of light, why it's so fast. Okay? But yeah, if you're going to try to do it with particles, not only are they one way, whereas a torsion works two ways, right? The standard wave, whether you take the standing wave or any kind of wave for that matter, other than the torsion wave, you have a one-way wave. One-way particle, one-way wave, and you cannot explain how the universe works with any of those two. Okay, what does he have to say about energy? Well, that's very quick. Here I've said it many times. It is important to realize that in physics today we have no knowledge of what energy is. Well, good old Feynman didn't realize that energy was not a what, and neither has any mathematician since then. Energy is not a what. Energy is a concept. What's are objects? An object is a what. So you can point to it, but you can't point to energy because energy is a mathematical concept. And he never realized that. So he's trying to figure out what is energy. I thought you didn't do physical interpretations, Dickie. Okay, and then energy, the capacity. That's what it is, the ability. That's how it's defined. And so, yeah, the capacity is not a physical object. Neither is the ability. And then what did he have to say about gravity? And remember, quantum mechanics has no idea what gravity is. So he says, what is gravity in his lectures, right? What about the machinery of it? All we have done is to describe how the Earth moves around the sun, but we have not said what makes it go. Yeah, that's what we want to know. Newton made no hypothesis about this. He was satisfied to find what it did without getting into the machinery of it. It's not that he didn't, Newton tried to figure out how it works, why it works the way it does. In other words, he wanted to figure out the mechanism. But he was thinking of particles also. He was an ether guy. He believed in the ether, particles, bunch of particles, and he could not explain it with particles. So he says, it just blows my mind how this could be happening. Yeah, if you propose particles, you cannot explain it, and Newton couldn't explain it, but he says, he did not delve upon that. Yeah, he did. He did, but he just couldn't explain it. And neither can good old Dickie here, right? So no one has since given any machinery. Yeah, they've given a machinery, not in quantum, but in general relativity, but it's an irrational one. They're saying that there's this thingy, concept, mathematical concept called space-time, and it bends. A concept that bends. Man, that's deep. A concept that bends, it's like love bending, intelligence bending, data bending, It is characteristic of the physical laws that they have this abstract character. No, they don't have this abstract character. Only in mathematics do they have abstract characters. The law of conservation of energy is a theorem concerning quantities that have to be calculated and added together. Again, they're talking math. They're not talking about physics. With no mention of the machinery, right? Because machinery is physics, right? And likewise, the great laws of mechanics are quantitative mathematical laws for which no machinery is available. Yeah, because they have the math, the equation, they have the measurements, but they don't have the proper assumptions about the invisible mediators or objects that mediate, the transactions, the phenomena. Why can we use mathematics to describe nature without a mechanism behind it? No one knows. Yeah, if you don't have the right assumption, the right hypothesis, as it's called, the right objects, the right mediators, you're not going to explain it. You're never going to be able to explain it. Okay, so one fellow asks about a question related to good old Feynman, says, we assume that the electron is a ball, indivisible, that it is not composed of other objects, but that it is unique and uniform. In other words, what he's saying is that it's made of a single piece. In short, that's how we say it in physics. It's made out of a single piece, period. This ball spins on itself. They call it spin. This ball turns and turns, but it always shows the same face, the same surface, properties, the same side. I wonder if it turns or if it is still. And so good old Dickey also, talked about spin, okay? And here it is. He says, spin should not be conceptualized as involving the rotation of a particle's internal mass, as ordinary use of the word may suggest. Spin is a quantized property of waves. So it's a wave that is spinning. So it's not a ball. That's the first one, The very earliest models for electron spin imagine a rotating charged mass. Yeah, mass is not is also a concept, so we don't have mass. Mass cannot rotate. A ball can rotate, not a number, not a mathematical concept. But this model fails when examined in detail. No kidding. The required space distribution does not match limits on the electron radius. The required rotation speed exceeds the speed of light. See, that's part of the problem why they cannot explain this. The classical analog for quantum spin is a circulation of energy. Energy circulates. I mean, what is it? Smoke? What is this energy thingy? Or momentum density in a particle wave field. Spin is essentially a wave property. As the name suggests, spin was originally conceived as the rotation of a particle around some axis. Yeah, that's what we think spin means, right? Historically, orbital angular momentum related to particle orbits. While the names based on mechanical models have survived, the physical explanation has not, right? Because you can't rotate numbers. You can't spin numbers or, quantities or abstractions. Quantization fundamentally alters the character of both spin and orbital angular momentum. Since elementary particles are point-like, self-rotation is not well defined for them. Yeah, what is the problem with this spin thingy that quantum has? Well, again, first, I cannot imagine how they can conceive of a wave spinning, especially a transverse wave, because a transverse wave is made of two fields, the light. It's made of two fields at 90 degrees to each other, and each field is just made of vectors. So what are we talking about? We're talking about numbers that are rotating. That's the problem. That's where it starts. Now, you need a physical object. You can say that a ball spins. You can talk about this spinning, okay? But what's the problem? To answer this fellow's question, if this is made out of a single piece, you cannot say it rotates. Because in order to rotate, you need at least two things. You need a center point and an edge point. If this is made out of a single piece, meaning very small, tiny thing made out of a single piece, you cannot imagine it rotating. You cannot conceptualize it rotating, because the only way we can imagine something like that happening is if the point on the outside compares against the point on the inside. And if it's made out of a single piece, you're going to try to imagine that as a ball made out of particles, where you have two particles and one is rotating around the other. So you cannot have spin in an object made of a single piece. And no one in mathematics ever resolved that, and that's why they use the word spin. They illustrate spin as spinning, as a top spinning, but then they tell you that's not spin. What do you mean? Is spin spin or is spin not spin? And they say, well, it is spin, so we illustrate it that way, but don't take the analogy so literally. Okay, with that, I'll see you next week, and hopefully I'll get rid of some of